Assalamualaikum warahmatullahi wabarakatuh. I will present about AI project and management of AI powered autism. So these are our members, led by Muhammad RIFQI ZAKIRIN. In this our project, autism spectrum disorder affects communication, social interaction, and behavior. Around 1 in 54 children are diagnosed, creating a strong need for better educational support. Traditional teaching methods often do not meet the individualized needs of children with ASD. There is growing demand for adaptive technology-based learning tools. AI-driven education enables personalized learning by analyzing learner behavior, adapting content to individual needs, providing real-time feedback. AI also can make learning more accessible, effective, and engaging for children with ASD. Move on to the case study. The AIsty project draws on several existing studies. First, augmented reality tools for interactive social and educational simulation. AI-based diagnostic tools using machine learning for early detection. Computer vision system for behavior and emotion analysis in therapeutic settings. This study informed AIST's design, emphasizing real-time adaptation, multimodal interaction, and caregiver involvement.
Hello everyone, my name is Muhammad Danish bin Omar. So our title for our group project will be AI powered autism learning module. Today I'm going to present about our detail on AI project management. So why is this matters and important to us? Because it highlight the social impact, improving communication, social and also cognitive skills for ASD learners using AI. So the first one, there is four project planning in our AI project management. The first one is develop an AI-powered adaptive learning module for children with autism spectrum disorder. In the short form is ASD to improve communication, social and cognitive skills. And then the second one is it identify the AI techniques. The third one is important because it plan tasks, plan the schedule, plan the budget and the risk for our project management. And then the last one is assign roles to team members. Second, we have work breakdown structure, which is WBS. We have five different type of WBS. The first one is planning and requirements. You should planning on start planning on the literature review, and then next you can go to requirement analysis, and then start with stakeholder interviews. Next, data collection and pre-processing. For the data collection, we collection of facial expression data sets, and then we do data labeling and also augmentation. Third is AI model development. CNN, as you know, as convolutional neural network, architecture design, and then we training, and then we do validation and also optimization. And then next is system development. For the GUI design, module development, fire-based integration. And lastly is testing and the deployment. We do unit testing, and then next we go to integration testing, and then usability study, deployment on local and cloud. So that's all from me.
Hello, my name is Muhammad NAFIS bin BADRUL HISHAM. I will be explaining the system flow for our system. So we start with a live webcam feed that captures the learner's facial data in real time. And then for the processing stage, using media pipe, the system detects and tracks the user's face accurately. And then we use a CNN-based emotion classification model to analyze facial expression and identify emotional states. For the output, the system delivers adaptive learning content, adjusting materially dynamically to match the learner's needs. At the same time, a real-time dashboard provides a caregiver or educator with instant visibility into the learner's engagement. All session data is securely stored in Firebase for tracking progress and long-term analysis. So now I will be explaining the algorithm behind our system and how we address key challenges. For emotion recognition, we use CNN. which is well suited for learning facial expression pattern from image data. To support accurate landmark tracking, we integrate MediaPipe, face mesh, and hands, allowing precise detection of facial and hand movement in real time. To determine user engagement, we implement a role-based state machine by combining emotional cues and facial activity. The system will classify engagement into clear states such as focused, distracted, or agitated. We also tackle several technical challenges. First, low emotion detection accuracy was improvised using data augmentation and transfer learning. Second, real-time latency was reduced by optimizing frame processing and applying modern quantization. Finally, to address user interface complexity, we designed a minimalist, sensor-friendly GUI using Tkinter, making the system accessible and comfortable for users. Thank you.
So next is about project implementation. This project will be gonna implement two module, which is the first one module is mathematical module. It will adaptive arithmetic games. And next is the children will be monitored by the system, and also we track the score and progress of the children. Next module is gonna be vision module. It will provide notification when children feel uncomfortable. You also will analyze the children readiness to learn. It also will provide detailed report of the analysis. And here is the output the gonna get. So the first picture is gonna be detect our face. We show the emotion of the children, and the below picture is the game, and the right one with will be gonna be the emotion analytical report.
Okay, Assalamualaikum. My name is Muhammad RIFQI. We are going to moving on with the main dashboard of AIsty. So this is the main dashboard of AIsty. As you can see, there are four minimalist buttons, which is shows the live feed, where there is analytic monitoring. Sing along with AIsty. It is for extra for the children having fun singing. Math with AIsty is our main module that I'm focusing on. Play game with AIsty. There is three mini games that children can have fun. So we go to main live feed one. In analytic monitoring, we can see that registered face shows my face with it. And from this segment, we can see the emotion trend, the three most highest emotions, and also what is the most frequent emotion. As you can see, it, it is always adapting the face, and the teacher can export the report. Moving on, for math with ICT, the children can play games that are based on mathematics. For what teacher will see is the leaderboard, where teacher can help the children who need help and who need to be focused. For example, we can use HAKIM. This is how it shows. It shows the level. We just answer the question, and it will gradually getting harder and harder. So from this, the background camera will always functioning. So that is why the limitation of the system is need higher power of computers. So imagine that this is running for many people. So that is why. So that is basically for me. This is IC. Thank you.
So in conclusion, the IST project successful developed an AI-powered vision-based learning module for children with autism. It demonstrates the feasibility of using real-time emotion recognition and adaptive learning to support communication, social, and cognitive skill development. While this current model show promising result, future work should focus on improving accuracy, expanding dataset, and conducting clinical trials. I still contribute to the growth field of assistive educational technology and offer a scalable, low-cost solution for personalized autism education. That's all for me. Thank you.